Hi guys, welcome back to my math YouTube channel. Now let us start looking at some application problems on solving right triangles. So guys, starting with example 1 here, I have this scenario where we have to find or approximate the height of the top of a mountain. So we have some given pieces of information. Guys, those are provided to me in words, and I'm going to, from the given pieces of information, I'm going to try to create a visual, and once we have a visual, we should be able to like kind of use the trig ratios and combination of other things that we have learned so far and figure out the missing values. Okay, so here I have this scenario where a person is looking directly at the top of a mountain. So let us try to create an approximate visual for this. So let us say this is my mountain, and somebody on the ground here, let's say at point A, is looking directly at the top of the mountain, and the angle of elevation that the line of sight makes with looking at the top of the mountain is already given to me. So let me draw that imaginary that line of sight. So this is that imaginary line of sight, and then this is that line of sight, and then it says the angle of elevation that it makes from point A onto the top of the mountain. And let us say this is the base of the mountain, and I'm going to try to create a right triangle, because anyway we want to create a right triangle so that we can then only we'll be able to use the trig ratios, right? So and we know that the angle of elevation is always measured with respect to the horizontal, and let me also draw that horizontal line here. And then this angle, which is already provided to me, is 35 degrees. Guys, then it says further, this person who is actually right here at point A, and now that person is moving towards the base of the mountain. So moving towards the base of the mountain, that person reaches to point B, and again the person looks directly at the top of the mountain, and the angle of elevation of the line of sight here, let me join this line of sight, and that angle of elevation is, guys, it is already given to me, but I quickly want to make sure that we understand how this thing kind of works. So as you are getting closer and closer, so if you think of this point something that can move, and as you get closer and closer towards this 90-degree right angle, we can clearly see that this angle is going to increase. So it makes sense here to see that the angle of elevation from point B is 50 degrees, because we can clearly see that as we go closer and closer, from point A towards this point, let us call this C, guys, the angle is going to increase, and that is what is already provided to us as 50 degrees. Then we want to approximate the height of this mountain, and let us call this height by h. And then there is one more piece of information that is provided to me here, is that this distance between point A and point B is already provided. So it says like the person moves 250 feet towards the mountain and reaches point B, and then this is the angle of elevation from point B. So guys, this is the distance that we already know. We don't know this distance from B to C. It's not asking us to find out that distance, but we would need it for calculation. So guys, let us assume that this distance is x. You can use any variable you like, but I'm going to say let this distance be x. So guys, this is the complete scenario. These are the pieces of information that are provided to us. From this, we have to figure out the value for, or the approximate the height of this mountain. So guys, in order to do that, there's few things that we have to keep in mind. One of the things that we have to recall is the trig ratios, so ka, toa. So sine, cosine, and tangent. Guys, keep in mind here we are interested in finding the height h. Now here we are not only dealing with one right triangle, we have basically two right triangles, and we have to use both the right triangles if we actually want to figure out the missing piece. Okay, so before we start doing that and using the trig ratios, guys, there's one thing that we have to observe, and then from that we can decide which trig function we should use here. Guys, the hypotenuse, so there's two triangles here. One is this bigger triangle, and then one is this other smaller triangle. Okay, and we have to work with both of these triangles one by one. If I look at both of these triangles, guys, this is the hypotenuse and this is the other hypotenuse for the smaller triangle. We don't really need to know the hypotenuse. And it's not even asking us to find the hypotenuse, right? So since it is not asking us to find the hypotenuse, that means there's no reason for me to use the sine, or even for that matter to use the cosine, because both sine and cosine have hypotenuse here. So we are not going to be using sine or cosine. What we're going to be using here is the tangent. It makes sense to use tangent because tangent it involves opposite and adjacent. This is the opposite, this is the adjacent. This is the opposite, and this whole thing is the adjacent for the bigger triangle. And we are interested in finding the h, which has to do with the opposite. Okay? So guys, the first thing is you want to make sure which trig function you want to start with. Since there's nothing to do with the hypotenuse here, we are not interested in finding the hypotenuse, so that's why we are not using sine or cosine, we are using the tangent. Now for tangent, we have to use tangent for two triangles. Let us use it for the smaller triangle. For the smaller triangle with tangent of 50, we're looking at just this triangle. So guys, the other thing that I want to tell you here is if you are looking at the smaller triangle, just forget about the other bigger triangle. Just focus only on the smaller triangle. For the smaller triangle, tangent of 50 we know is opposite over adjacent. What is the opposite? H. And what is the adjacent? Just the x. Okay, so I just wrote this equation. From here, let us also at the same time, let us also write the other equation for the tangent of the other angle, which is for the bigger right triangle. So for the other bigger right triangle, the reference angle being 35, what is tangent of 35? Guys, tangent of 35 degrees is again opposite over hypotenuse, but the opposite here is opposite over adjacent. I'm sorry, opposite is h, but adjacent is a combination of two things. So this whole AC is the adjacent, right? But it can be written down or broken down as x plus 250 or 250 plus x. So I'm going to write x plus 250. So it is this plus this, and I'll put it in the parentheses. So these are the two equations, and from these two equations we'll be able to figure out h and also x. Although we don't need x, but sometimes we have to find some extra information in order to find what we really need to find. Okay, so how are we going to solve, or how are we going to work with these equations? Guys, it is not too complicated. What we do here is cross multiply, right? That's what we have been doing with other these sort of ratios when we have to solve for any missing sides or angles. We cross multiply. If I cross multiply, I get h equals to x times tangent of 50. Pretty simple. 1 times h is h, and x times this is tangent 50. So let us preserve this, and then here if I cross multiply, h times 1 is still h, and I get x plus 250 times tangent of 35 degrees, right? That is what we get when we cross multiply. But guys, if you look at these two equations carefully, there's an h here, there's an h here. So h and h is basically the same. They are the same h. So if this and this is the same, then the right hand sides are also supposed to be equal to each other. So from these two equations, what we can conclude here is that this is going to be equal to this. So we are going to set them equal to each other. So it is x tangent of 50 equals to x plus 250 times tangent of 35. Now in this equation there is no h, but guys, that is fine, because from this equation we can solve for x. Once I have the value for x, I can go back to any of these equations and we can solve for h. Okay, so let us try to solve this equation carefully. It is not such a complex equation, but we will go through all the steps carefully. So how are we going to do that, guys? I have to get rid of some of this here. So let me get rid of this so that we have some more room here to work with this equation. So what I'm going to do here is, I'm just taking it up from here to here, guys. So it is x tangent of 50, and then here I'm going to distribute this tan 35 like this and this. So it's going to be x tangent of 35 plus 250 times tangent of 35. We just distributed this. Since I want to solve for x, so what I'm going to do is I'm going to bring this term to the left hand side. So I will subtract this from both sides. That way I can bring it to the other side. So when I do that, I get x tangent of 50 minus x tangent of 35. We are trying to isolate x, okay? And then on the right hand side, I'm only left with 250 times tangent of 35. Guys, I'm not going to be using calculator yet. I will do it all the way at the end. From here, we can see that x and x is the common factor, or the greatest common factor. And we can put this in the parentheses. Tangent of 50 minus tangent of 35 will be in the parentheses. On the right hand side, I still have 250 times tangent of 35 degrees. To get x by itself, we got to divide both sides by tan 50 minus tangent of 35. Okay, and if we divide this, we got to divide the right hand side as well. So this tangent 50 minus tangent of 35 degrees. This crosses out. From here, what do I have? I have x equals to, and we wanted to solve for x, even this equation. guys, you got to simplify this using a calculator. The key here is that the denominator, when you put this whole thing in a calculator, you got to put the denominator in the parentheses. Because this is a binomial, guys, that's why we want to put it in the parentheses. Otherwise, you will get a different answer. So when you put it in a calculator and you put the denominator in the parentheses, this is what I get for x. I get x equals to 356.12. So I went up to 2 places of decimal. So that is the value for this x. But it is not actually asking us to find the x, but we had to find x to find h. So once we have the value for x, then guys, you can look at these two equations which I have actually boxed here. You can put that x right here and you can solve for h, or you can even use this equation. It seems like this equation is easier to work with, although if you put x here or here, you are still going to get the same answer. So I mean, if you want to verify, you can use both the equations and see that if you get the same answer. But right now, I'm only going to use this one. It is easier to work with this. So for this equation, let me get rid of some more stuff here so that we can see the final solution. So guys, I don't need this piece. So for now, we have to put this back into this equation, and the height, the approximate height of this mountain is x times tangent of 50. X is 356.12, and this has to be multiplied by the tangent of 50. Again, using my calculator, I did all that calculation, so it is 424.41 feet. I went up to 2 places of decimal. So this is the approximate height of this mountain. And that answers this question for me, guys. So these are the application problems. I started with number 1. Guys, I'm going to show you many more different types. There is so many different types in here. We will try to see as many types as we can, but guys, it is not too complicated. But the key here is to first draw a visual, which always is kind of going to be a right triangle, because we're still working with only right triangles, because these trig ratios, trig equations, trig functions are only valid for right angle triangles. So in this whole application section, we would still be drawing right triangles, but we have to kind of visualize, create those triangles, draw the angle of elevations or angle of depressions. Maybe in the next example, I'm going to show you an example with angle of depression. Guys, from there, we got to set 2 equations depending on how many right triangles we're dealing with. Here we had 2 right triangles, so we started by setting up 2 equations. From there, guys, we basically have to do the math carefully. It is more like doing the algebra piece, okay? So guys, please spend some time thinking about this problem, watching and looking and doing these steps, and then you will definitely get more confident as we learn more application problems. Till then, guys, take care. I will see you next time.